Today we are going to learn about facial recognition systems, building and bias mitigation. We will explore how to build facial recognition models and implement strategies to reduce bias, equipping you with the skills needed to ensure fairness and ethics in AI systems.
Welcome to our exploration of facial recognition systems. Facial recognition technology has become a pivotal part of modern life, used in everything from unlocking smartphones to airport security. However, as this technology becomes more pervasive, concerns about privacy, accuracy, and fairness have come to the forefront. In this video, we'll take a deep dive into building these systems and implementing strategies for bias mitigation. We'll cover the full process, from setting up a project and collecting diverse datasets to training models and evaluating bias. Our goal is to provide you with the knowledge and tools needed to create facial recognition systems that are not only effective but also fair and ethical. Let's get started.
Facial recognition technology involves the identification or verification of individuals using their facial features. At its core, the technology captures an image of a face, analyzes the unique features, and compares it to a database of known faces. This process generally includes several key components: detection, alignment, and recognition. Detection involves finding the face within an image, alignment ensures the facial features are in a standardized position, and recognition matches the face to identities in a database. Despite its advanced capabilities, facial recognition systems face challenges such as varying lighting conditions, facial expressions, and the need for diverse training data to ensure accuracy. As we delve deeper into this topic, we'll explore how these systems are built and how we can address inherent biases to create fairer and more ethical AI solutions. Setting up a facial recognition project is a critical step that requires careful planning. The first task is to define the project's goals and scope. Are you developing a system for security purposes, consumer applications, or research? Your objectives will guide the selection of tools and frameworks, such as OpenCV, glib, or TensorFlow, which are popular choices for facial recognition projects. Assembling a team with diverse expertise is also crucial. This should include data scientists, software engineers, and ethicists to ensure a well-rounded approach. Establish clear timelines and milestones to track progress and adjust strategies as needed. From the outset, consider how you will address bias in your system. This might involve setting goals for diverse data collection and planning for iterative testing to evaluate fairness. By laying a strong foundation, you can ensure your project is both successful and ethically sound.
A foundational element of any facial recognition system is the dataset used for training. The importance of using diverse datasets cannot be overstated, as they are crucial for reducing bias and ensuring the system's accuracy across various demographics. Data can be sourced from public databases, such as the LFW, labeled Faces in the Wild, dataset, or through proprietary collection methods. Each source has its ethical considerations, particularly regarding consent and privacy. Pre-processing is another critical step, involving tasks like data augmentation, normalization, and ensuring the dataset is balanced across different demographic groups. This requires a careful balance between diversity and data quality, as skewed or inadequate data can lead to biased models. By focusing on creating a comprehensive and representative dataset, you lay the groundwork for a fair and effective facial recognition system. Once you have your dataset prepared, the next phase is training your facial recognition model. This begins with selecting an appropriate model architecture. Convolutional neural networks, CNNs, are commonly used due to their proficiency in image recognition tasks. Training involves using algorithms like backpropagation to optimize the model's parameters. Hyperparameter tuning is crucial, as it can significantly affect the model's performance. This involves adjusting parameters like learning rate and batch size to find the optimal configuration. Iterative training and validation are performed to ensure the model is learning effectively. During this process, it's important to watch for signs of overfitting, where the model learns the training data too well and performs poorly on unseen data, or underfitting, where the model is too simple to capture the data's complexity. By meticulously training your model, you increase its accuracy and reliability.
After training your model, the next step is evaluation, where you assess both accuracy and bias. Accuracy can be measured using metrics such as precision, recall, and F1 score. These metrics provide insights into how well the model performs on both the training and validation datasets. Identifying bias involves evaluating the model's performance across different demographic groups to detect any disparities. Tools such as fairness indicators or equitas can aid in this assessment. Cross-validation is essential, as it ensures that the model's performance is consistent across various subsets of the data. Continuous monitoring is necessary, as model performance can degrade over time due to changes in data or deployment conditions. By maintaining a rigorous evaluation process, you can ensure your model remains accurate and fair. Bias mitigation is a critical component of developing ethical facial recognition systems. Understanding the sources of bias, such as data imbalance or algorithmic limitations, is the first step. Techniques like data augmentation and balancing can help address these issues by ensuring diverse representation in training datasets. Algorithmic fairness techniques, such as adversarial debiasing or reweighting, can adjust model parameters to promote fairness. Regular auditing and adjustments are necessary to identify new sources of bias and adapt the model accordingly. An inclusive design approach, which involves diverse teams and perspectives throughout the development process, can also mitigate bias. By implementing these strategies, you can create systems that are more equitable and ethical. Implementing fairness metrics is an essential step in ensuring your facial recognition system is equitable. Different types of fairness metrics exist, including demographic parity, equality of odds, and fairness through unawareness. Each offers a unique perspective on what fairness means in practice. Integrating these metrics into your model evaluation process helps ensure that your system performs equitably across different user groups. Tools like AI Fairness 360 or Themis ML can aid in measuring and analyzing fairness. Defining fairness is challenging due to its subjective nature, requiring alignment with ethical goals and societal values. By implementing fairness metrics, you can guide your model development towards more ethical outcomes. As facial recognition systems are deployed, navigating the legal and ethical landscape becomes increasingly important. Understanding privacy laws, such as GDPR in Europe or CCPA in California, is crucial, as these regulations govern the collection and use of personal data. Ethical implications, including potential misuse or invasion of privacy, must be considered. Navigating regulatory environments requires staying informed about current laws and potential changes. Ensuring user consent and protecting data should be priorities, with clear communication about how data is used and secured. Developing transparent AI systems, where users can understand and trust the technology, is essential for ethical deployment. By considering these factors, you can responsibly integrate facial recognition systems into society.
The future of facial recognition technology is both exciting and challenging. Advancements in machine learning and AI promise more accurate and efficient systems, with potential applications ranging from personalized customer experiences to enhanced security measures. However, as technology evolves, so do regulatory landscapes, requiring continuous adaptation and compliance. The potential for new applications must be balanced with ethical considerations, such as privacy and bias. Continuous improvement and innovation will be key, with ongoing research needed to address challenges and opportunities. By focusing on responsible innovation, the future of facial recognition technology can be both groundbreaking and ethical. Examining case studies of successful bias mitigation provides valuable insights into real-world applications. For example, companies like IBM and Microsoft have implemented comprehensive bias reduction strategies, resulting in more accurate and equitable facial recognition systems. Lessons from these projects highlight the importance of diverse data, regular auditing, and transparency. Effective implementation strategies focus on continuous improvement and stakeholder engagement. Bias reduction not only enhances accuracy but also builds public trust by demonstrating a commitment to ethical AI. These case studies offer important lessons for developing fairer and more reliable systems. As we conclude our exploration of facial recognition systems, it's clear that building these systems involves more than just technical expertise. It requires a commitment to fairness, ethics, and continuous improvement. Bias mitigation is not a one-time task but an ongoing process that demands vigilance and adaptation. The role of ethics in technology is paramount, guiding decisions and ensuring that AI serves humanity positively. As we look to the future, our vision is for AI systems that are both innovative and responsible, contributing to a more equitable world. Thank you for joining us on this journey to build fair and ethical facial recognition systems.